Hello friends, welcome to today's lecture Principal Stresses and Strains. Myself, Mr. Y. S. Patil, Department of Civil Engineering, Sharad Institute of Technology, College of Engineering, Yatgaon. In the last lecture, we discussed about a member subjected to two mutually perpendicular stresses. Now, in this lecture, we discuss about a member is subjected to simple shear. Now, so this is a member, that is this is a plane ABCD having acting a shear force, that is tau, along the faces. So due to this shear stress, what are the normal stress and tangential stress produced in the section is calculated. So let us see. So due to the shear stress, first calculate Q1. Q1 is a shear force on face BC. How to calculate shear force on face BC? That is shear stress into area of BC. The shear stress becomes tau into BC into 1. That is Q1. That is tau into BC into 1. That is Q1. That is tau into BC. Then next Q2. Q2 is equal to shear force on face FB. So tau into area of FB, that is tau into FB into 1, that is tau into FB. So by this is a Q1 and Q2. Then we require to find out Pn and Pt. Pn means total tangential force on the section FC and total tangential force on section FB. This is the FC. So this I want to solve this Q1 and Q2 solve on the basis of this FC line. So y component, that is perpendicular component, is Q sine theta. So this is the Q1, that is Q1 is tau B into BC into 1. With respect to this FC, the Q1 angle is theta. So it becomes Q1 sine theta, and vertical component, horizontal component is Q1 cos theta. Similar way, this is a Q2 on this FB is Q2 is equal to tau into FB into 1. So it becomes tau FB1, and I want to resolve with respect to this FC line. So this is the theta. So it becomes Q2 cos theta and Q2 sin theta. So total normal force, that is Pn, is equal to Q1, that is normal, Q1 sin theta plus Q2 cos theta. This is the Pn. And Pt is tangential force is Q1 cos theta and Q2 sin theta. So Q1 sin cos theta is downward direction, Q2 sin theta is upward direction. So consider Q2 sin theta is positive, Q1 sin theta is a negative. Then normal stress is equal to total normal, that is Pn divided by area of FC, and Pt, that tangential stress, is equal to Pt is total, that is Pt divided by area of FC. So putting this Pn and Pt value and area of FC value, we got sigma n is equal to tau sine 2 theta and sigma t is equal to minus tau cos 2 theta. This is normal stress and this is the tangential stress when a member subjected to simple shear. The next, a member is subjected to two direct mutually perpendicular stresses, simple shear. In previous lecture we discussed just only two perpendicular components, that is sigma 1 and sigma 2. In this problem in addition to that sigma 1, sigma 2, there is one shear stress, that is tau, is acting on the member. Means the condition number 2 and condition number 3 is additional. Now this is the fourth condition, means two perpendicular forces with a simple shear. So first we required, already we know how to calculate P1 and P2. P1 becomes sigma 1 into BC into 1, and this is perpendicular, and P2 becomes sigma 2 FB into 1. So resolve these two perpendicular component with respect to FC line. So first component, that is P1, is P1 cos theta and P1 sin theta. Due to this P1, two perpendicular component is P1 cos theta and P1 sin theta, and due to that P2 is P2 cos theta and P2 sin theta. This is the four perpendicular components due to sigma 1 and sigma 2, that is 2 for P1, that is P1 cos theta and P1 sin theta, and 2 for P2, that is P2 sin theta, P2 cos theta. Similar way, one external shear stress is applied along this face, so we need to require that that component also. So that is Q1 is equal to, that is tau into BC into 1, and component for that Q1 is Q1 sin theta and Q1 cos theta. Similar way, Q2 becomes tau into FB into 1, and the component becomes Q2 cos theta and Q2 sin theta. So external applied forces 3, and now component becomes 6 with respect to this FC line. So sigma n becomes sigma 1 into cos theta plus sigma 2 into sin theta plus tau sin theta and plus tau into cos theta. This is the four components divided by area of this FC. So solving this equation, we get sigma n is equal to sigma 1 plus sigma 2 divided by 2 plus sigma 1 minus sigma 2 divided by 2 into cos 2 theta plus tau sin 2 theta. This is the normal stress. Similarly, we consider first calculate PT, that is tangential force. Tangential force due to this P1, P2, Q1 and Q2 by considering this component of these four stresses. So it becomes sigma T is equal to sigma 1 minus sigma 2 divided by 2 into 2 cos theta sin theta minus tau in bracket cos square theta minus sin square theta. This is a tangential force. Then due to that shear stress, it generate a principal plane. So we require to find out that principal plane. First of all, what is meant by principal plane? The plane which having no shear stress are known as principal planes. Hence, principal planes are the plane of zero shear stress. So how to find out that principal planes? That for the principal plane, the condition is sigma t is equal to 0. So we know the sigma t value, that is sigma 1 minus sigma 2 divided by 2 into sin 2 theta minus tau cos 2 theta. It becomes 0. So sigma 1 minus sigma 2 divided by 2 into sin 2 theta is equal to tau cos 2 theta. So sin 2 theta divided by cos 2 theta is equal to tau divided by sigma 1 minus sigma 2 divided by 2 is equal to 2 tau divided by sigma 1 minus sigma 2. So tan 2 theta becomes 2 tau divided by sigma 1 minus sigma 2. It is a position of principal plane. By using this equation we can find out theta. Then measure principal stress. So for find out the major principal stress, the equation becomes sigma 1 plus sigma 2 divided by 2 plus square root of sigma 1 minus sigma 2 divided by 2 bracket square plus tau square. Then minor principal stress becomes sigma 1 plus sigma 2 divided by 2 minus square root of sigma 1 minus sigma 2 divided by 2 bracket square plus tau square. This is the formulas to find out position of principal planes and principal stresses, that is major principal stress and minor principal stress. Then sigma T max is 1 by 2 in square root of sigma 2 minus sigma 1 bracket square plus 4 tau square. And already the position of the principal plane is tan 2 theta is equal to sigma 2 minus sigma 1 divided by 2 tau. Let us see an example. At a point within a body subjected to mutually perpendicular direction, the stresses are 80 Newton per mm square and 40 Newton per mm square tensile. Each of the above stress is accompanied by a shear stress of 60 Newton per mm square. Determine the normal stress, shear stress and resultant stress on an oblique plane inclined at a 45 degree with the axis of the minor tensile stress. So first major tensile stress becomes sigma 1 is equal to 80 Newton per mm square, minor stress becomes sigma 2 is equal to 40 Newton per mm square and shear stress tau is 60 Newton per mm square. So angle of the plane with the minor axis tensile stress, that is 45 degree. So this is the theta is equal to 45 degree. So first of all find out normal stress, that is sigma n. So equation for that sigma n is sigma 1 plus sigma 2 divided by 2 plus sigma 1 minus sigma 2 divided by 2 into cos 2 theta plus tau sin 2 theta. So sigma 1 is 80 Newton and sigma 2 is 40 Newton and both stresses are same direction, that is tensile. So consider both values are positive. 80 plus 40 divided by 2 plus 80 minus 40 divided by 2 into cos 2 theta, that is cos in bracket 2 into 45. So it becomes cos 90 plus 60, that is shear stress, into sin into 2 theta, that is 2 into 45. So simplifying this equation we get sigma n is equal to 120 Newton per mm square. Then next tangential stress, that is sigma t. So sigma t is equal to sigma 1 minus sigma 2 divided by 2 into sin 2 theta minus tau cos 2 theta. So sigma t becomes, put up all values, that is sigma 1, sigma 2, tau and theta. We get sigma t is equal to 20 Newton per mm square. Then resultant stress, that is sigma r. Sigma r is easy to calculate if you know the sigma n and sigma t. So sigma r is equal to square root of sigma n square plus sigma t square. So 120 Newton per 120 square plus 20 square and take the square root. So sigma r becomes 121.655 Newton per mm square. So this is a solution for a member subjected to two perpendicular forces with a shear stress. Thank you.